Okay, welcome to this video tutorial on physics problem solving, in particular a particular SUVAT calculation with a decelerating train. Okay, so I'm going to lay it out for you. I've already read the question. A train decelerates over an interval, but then we know that it continues on in that pattern. So it decelerates from 35 meters per second to 21 meters per second. Note from the fifth multiple of 7, 5 sevens, 35, to 3 sevens. So it's decelerated by 2, so let me mark this as a 2. And then this is 3 sevens. So time, on the time scale, the proportionality will be divided into the scale of 2s to 3, which will be important in the second part of the question. Okay, let's get the first part of the question out of the way. The question is the deceleration. Calculate the deceleration. Okay. Well, now this is 2t and this will be unknown, so it's no good to us. What we do know is it's 350 meters is travelled during this deceleration period. So the acceleration equals v squared minus u squared over 2s. That's just over 2s. That's a rearrangement of the third equation from the log tables. So basically, on your log tables, the very first page is all maths, and the second page is all physics. Okay, so it starts off interestingly enough with some particle physics. Fascinating stuff, and there's mechanics involved here, but we get into classical physics, and it is the beginning of the story of science. Anyway, so we're heading to page 58. Thereabouts. When I say thereabouts, just that's where mechanics starts. In particular, it's page 50, so you might want to get to know this. If nothing else, just as a reference to know where new equations are coming from. You should know these formula and so on. And you've learned how to derive 1, 2, 3 and 4. Indeed, this fourth one is a stepping block for this one above it. So it's nice to know that by opening your log tables, it reminds you how to derive this one by looking at this one. Okay, so we've used v squared equals u squared plus 2as. And we get 35 squared. Just some interesting things here. If you're squaring a number that ends in 5, you can go up 1 from there. 3 4s is 12. So it'll be, not that it matters what I do now, because the calculator is going to do it all anyway. But I'll just tell you that would be 1225, because that's the square of 35. And 21 has an interesting square because it's the reverse of the square of 12. So minus 441. All over double the displacement is 700. And another way of doing that, I just want to show you the difference of 2 squared. Oh, sorry, one other thing. V squared is the final velocity, so that should read the other way around if we're doing it with correct signs. So 441 minus 1225 all over 700. Okay? And the days of using difference of 2 squares for calculations are kind of over, because now we have calculators and we don't have to be efficient regarding the scale of numbers we end up on when we're filling it in. So we'll just ignore I just wanted to show you that, but after that we'll ignore it. And we just go with, hey, what is 21 squared minus 35 squared all over 2s? Well, I think we should be able to handle double 350 in our heads without worrying. So that's the answer for the acceleration. It'll be a negative value. Okay, it's 28 over 25, which I can look at decimally, but of course we know what that is decimally. It'll be 0.12 minus 1.12. Have a look at it anyway. I'm in scientific mode, which should 3 decimal places, and that's what I suggest we'll do nearly all of our calculations in the course. There are times when you might want to use fix for sines and cosines, but however, even then, the scientific, which is the mode is here, I did shift mode and I'm looking at 7, is a fantastic option. And you don't need 7, 8, 9 figures of precision. It's complete nonsense often based on the accuracy of the input data. So you want to typically take 3. Now you know how to do this. So minus 1.12. The acceleration equals minus 1.12 meters seconds to the minus 2. Okay. Now here comes this fancy bit that I didn't use in a class solution, which I should have done. It's based on the fact that the time that they're asking us to calculate is really what's 5t, based on whatever this unit of t is, which is 2 of them were used up to get from there to there. So I'm going to calculate t based on this area. How do I do that? Well, I know that the average, and I'll bring you back to this, the displacement is equal to the average velocity over 2 multiplied by the time. Well, we know everything in that equation except time. Okay, so basically I will say, and let's make time the subject of this formula. So t equals twice the displacement over the sum of the initial and final velocities. Okay, which is equal to 700. Now I have to be careful here. This, for me, the time is 2t. So in this case, 2t is equal to, and look, the twos go away. So I can say t now, an individual t, equals the displacement over the sum of these two, which is 56. And our answer, total time, which is equal to total time, equals 5t, equals 5 of them. Okay, so we'll just let the calculator do all that. 5 by 350 over 56. I have a tiny bit of space here to give the answer. Okay, still in scientific. You're probably going to find me in scientific mode for an awful lot of the course. 5 by 350. I forgot to do my fraction bar. It's not too late to just start one now. Over 56. Okay, shift equal. It'll be hard to force it not to give me a fraction, except I have to push SD. Okay, which is 31.3 meters. Sorry, 31.3 seconds. Okay, and I just want to flick and look at the actual solution just to verify that the one that we were dealing with was the same. 31.25. We got 31.13. Yeah, now our answer is correct. They have rounded, they've carried a rounding error. Probably based, I just want to check on one thing. I want to check, is this rounded or is it exactly right? To go back to do that, I want to go all the way back and calculate the whole thing again based up here, which is 21 squared. And what I'll do is I'll turn my calculator back to normal mode just to settle the issue. So I'm going 8-1 fraction bar, and 21 squared minus 35 squared all over 700, double that. I just want to see. Well, they've done something silly because the answer is, we've got the answer right, 31.35 seconds. Okay, hope you enjoyed that.